Hello everyone! In this video, we're going to learn on how to choose the appropriate statistical test to be used in a certain statement of the problem or a given research question. Statistical tests are used in hypothesis testing. They can be used to compare means between two or among groups, determine whether there is a statistically significant relationship between two variables. You can perform a statistical tests on data that have been collected in a statistically valid manner, either through an experiment, survey, or observation made using probability sampling methods. For a statistical test to be used, your sample size needs to be large enough to approximate the true characteristics of the population being studied. To determine which statistical test to use, you need to know whether your data meets certain assumptions and the types of variables or level of measurement that you're dealing with. Assumptions like independence of observations, homogeneity of variance, and normality of data should be satisfied by a given set of data before you can use a particular statistical test. You may watch my other videos for these topic assumptions, of the different statistical tests. For the levels of measurement, we have four. We have nominal, ordinal, interval, and ratio. When we say nominal, it consists of names, labels, or categories. Examples are gender and nationality. Ordinal comes from the word order or rank. Differences between data values either cannot be determined or are meaningless. Examples are educational level and hotel classification. The third level is interval. Meaningful amounts of differences can be determined. It has no inherent natural zero starting point. Examples are temperature and IQ score. For ratio, the highest level, it includes the inherent zero starting point. And examples are weight and test scores. Let's have an example of a variable, monthly income. If this variable is included in your survey questionnaire, so in that survey questionnaire, the data to be collected can be any of these which belongs to any of the levels of measurement. Let's say, for example, you want your participants or respondents to just choose between with income or no income. The data that you are collecting is actually in the nominal level. But if you want your respondents to describe their monthly income as to low, middle, or high, your data is actually in ordinal level. And if you want to collect data like 5,001 to 10,000, 10,001 to 15,000, and so on, you did not actually start with zero, in counting or in measuring. That is actually in the interval level. And if you ask your participants to just fill out the blank in your questionnaire for monthly income, and then they will answer like this: 35,600, 78,500. These data are actually in the ratio level. So in here, it means that a certain variable can be actually belong to any of the level. It depends on the data that you are collecting. Let's have another example, academic performance. So first of all, you need to actually operationally define this academic performance in your research paper or in your thesis paper. And then you need to actually decide what measurement or data you will be collecting. Is it actually the exam scores? Is it actually the grade or test scores? Or maybe their average grade, okay, in a particular semester. So, so for example, if you want just to ask your students to classify whether they passed or failed the subject, your data is actually nominal. But if you want your students to describe their academic performance as to excellent, very satisfactory, satisfactory, and so on, your data is actually in ordinal level. Okay, but if you gather data like 75 to 79, 80 to 84, and you did not actually start with 0 as the starting point, that's actually interval level. And if you gather average grade like 95.36, 85.79, 95.07, or there's maybe their scores or weighted mean like that, those are actually in ratio level. Okay, so that's it. No, that's how a certain variable actually belong to a certain level. Okay, it depends on the data you are actually collecting, and this level of measurement, okay, actually affects, okay, the choice of statistical tests to be used in your study. It's actually one of the criteria in choosing the appropriate test to be used in a research paper. Okay, so let us now align some objective of your research with those with that of statistical test. Let's say, for example, you want to compare means or find the differences between two or more groups. Possible statistical tests to be used in your study will be t-test and ANOVA. But if you're looking for significant relationships or associations between two or among variables, possible statistical tests to be used are Pearson R and chi-square test. And if you want to predict the value of one variable from the other variable, you may use linear regression. These tests are actually grouped into comparison tests and correlation tests. When we say comparison tests, these are the tests of significant difference. So you're looking or finding or comparing the differences between two or among group means. They can be used to test the effect of a categorical variable and the mean value of some other characteristic. Examples of tests for significant difference are t-test and ANOVA. So t-tests are used when comparing the means of exactly two groups. Okay, so if you are going to compare the average heights of men and women, you may use t-test. ANOVA is used when comparing the means of more than two groups, like comparing the average heights of children, teenagers, and adults. This is the summary or a table for the test of significant difference. We have what we call parametric test. So we will, in this video, we will focus on this parametric test, and then there's what we call non-parametric test. Okay, one major difference of these two is for parametric tests, your data should be approximately normally distributed. And your data here are numerical, they are interval or ratio level. Otherwise, if your data are not of those characteristics, you may use the non-parametric test. Let's have comparing the means of two independent groups, two different groups. If the variable or the independent variable is categorical, okay, should be nominal or ordinal, and your dependent variable, this one is the one being measured or gathered, the dependent variable, it should be quantitative or numerical, and it means numerical means these are in the interval or ratio level. In our SPSS software, these two are termed as scale. So you may use independent t-test. If you are comparing means of three or more independent groups, three different groups or more, you need to use one-way ANOVA. If you are comparing the mean difference between paired or matched samples, okay, you may use paired t-test. And if you are going to compare three or more measurements on the same subject, you may use repeated measures ANOVA. So these are the tests of significant difference. The next group of tests is what we call the correlation test, or test of significant relationship or association, to actually determine whether there is a relationship between two variables. And this does not mean that the relationship is actually cause and effect. It's not. So this is the table for the test of significant relationship. Okay, so if your independent variable or the predictor variable is quantitative, meaning numerical, or that's interval, ratio, or scale, and the other variable, the dependent variable, is also numerical, you may use parametric tests, okay, which is the Pearson R. Okay, but if you are relating two categorical variables, one variable is categorical, meaning nominal or ordinal, and the other one is also nominal or ordinal, you may use the chi-square test. Okay, and if you want to predict, okay, or estimate the value of one variable from the value of another variable, you may use the simple linear regression. Let's have an example of a research question or a statement of the problem, and we're going to actually identify the dependent and independent. And in this example here, these are the research question or statement of the problem wherein we can use the independent sample t-test. Okay, like for example, the research question is, what is the difference in average exam scores for students from two different schools? Okay, so our independent variable is categorical. That is school, and we have two groups, school A and school B. And the dependent variable should be numerical or quantitative. That is the exam scores. So that's correct. You can use independent sample t-test. The next one is, the salary of private school teachers differs significantly with that of the public school teachers. So our independent is categorical. These are the school teachers from the private and public. So there are two different groups. And the dependent variable is numerical. We are comparing the salaries of the two groups. So you can use independent sample t-test. Another statement of the problem: is there a significant difference in the academic performance of the participants when grouped according to gender? So we have here the independent variable. It's categorical, that's gender. We have two groups, male and female. And the independent is actually numerical, that's academic performance in terms of grades. Okay, is there a significant difference on the antibacterial property of Mayana leaf extract and santan leaf extract? So here we are comparing two. Those are the Mayana and santan. Okay, these are the treatments, two treatments. And the numerical value here is the antibacterial property in terms of the mean zone of inhibition. So it's something numerical. Let's have an example of a data wherein we can use independent sample t-test. This is the SOP. Is there a significant difference in the academic performance of the participants when grouped according to gender? Okay, so to actually tabulate or organize your data in a Microsoft Excel or even in our SPSS software, you may have this. The first column may be the participant number or respondent number, and then second column will be their gender, male and female, and the third column will be the academic performance in terms of their grades. So this is actually just 10 participants, but you may actually add more here or add more rows if you have more respondents. So that's how to actually tabulate or to organize our data so that we can actually later on analyze and interpret it using SPSS. Another, is there a significant difference in the antibacterial activity of the mayana and santan leaf extracts? So this is a pure experimental research, and actually it requires replicates. So let's say, for example, you have 5 replicates here, and then you actually measure the mean zone of inhibition for the mayana leaf extract group, and then the santan leaf extract group or experimental group. So there are 2 groups here. That's why you can use independent sample t-test. Okay, and these are in millimeters. They are numerical data. So you can have organize your data like this, but if you want to treat this using SPSS, you may convert it to a table like this. Okay, in your Microsoft Excel or immediately in your SPSS. So you need to do coding for the treatment group. So you may use 1 for mayana and you may use 2 for santan. And then you have 5 replicates here. That's why you have 5 ones here. And then you have 5 twos here for the santan. And then you copy the data for the mean zone of inhibition for the first group. That's it. And for the second group, you copy this. And that's how to organize our data so that we can interpret it or treat the data using our SPSS. Let's proceed to the paired samples t-test. For a research question, or what we call SOP, is students' conceptual understanding of derivatives improved after the implementation of the new strategy? So our independent variable here should be numerical, and our dependent variable, it should be categorical, and our dependent variable should be numerical. So our independent here is the new strategy. And for a paired sample t-test, it may require a time, because you need to gather data at different points in time, period of time. So that's why we put here time. So because there is actually a clue here, we have what we call the before and after the implementation of the new strategy. So our dependent variable here is actually the student's conceptual understanding through a test. That's why the data gathered will be test scores. Is there a significant difference between the participants' pre and post-test scores in science? So the independent variable is a certain strategy. It's not mentioned in this SOP, but I'm sure that there should be a certain intervention or a certain strategy used here. And then we are going to compare the test scores, the pre and post test scores. So you may use here paired samples t-test. Another example, is there a significant difference in the technical writing skills of the participants before and after the seminar workshop? So the independent is actually the seminar workshop. This is actually the strategy used, or the intervention or the treatment. And then there is actually the element of time here, because you need to measure a certain property at 2 different period of time. So the dependent variable is the technical writing skills, which can be measured by giving an exam or a test. So the data to be gathered will be their test scores before and after. And then let's have another SOP. Is there a significant difference in the mean blood glucose level of the experimental group before and after induction of serpentina leaf extract? So our independent variable is actually our treatment, that is using serpentina leaf extract. And then there's an element of time. We have what we call the before and after, in measuring the blood glucose level, of the experimental group. So in this statement or the problem or research questions, we're going to use paired samples t-test. Let's have some sample data for paired samples t-test. For this SOP, is there a significant difference in the technical writing skills of the participants before and after the seminar workshop? So let's say we have 10 participants here. So before you implement or you conduct the seminar workshop, you need to give pre-assessment or pre-test to these participants. So you get their pre-test scores, and then now they will undergo or attend the seminar workshop. So after attending the seminar workshop, you need to again give the same or similar tests to them to measure their technical writing ability or skill. And that will be the post-test scores. So comparing these pre-test and post-test scores, you need to use paired samples t-test. Another example in pure experimental results. For this SOP, is there a significant difference in the mean blood glucose level of the participants? Blood glucose level of the experimental group before and after induction of serpentina leaf extract. So since this is actually an experimental research and we have a treatment here of leaf extract, so our subjects here are rats, no? So let's say, for example, there are 5 rats here for the replicates, and you have to measure the blood glucose level before and after the induction of serpentina leaf to actually determine the effectiveness of this serpentina leaf extract. Okay, so in here you need to use pair sample t-test. For the analysis of variance, or what we call ANOVA, okay, we know that this is used to compare 3 or more groups. Okay, so for this research question, what is the difference in average exam scores for students from 3 different schools like A, B, C? So we have 3 groups being compared. The thing that we have to compare here is the exam scores. So you can use ANOVA. For this research question, are the salaries of teachers in the elementary, high school, and college level differ significantly? So there are 3 groups here of teachers as to school level. We have elementary, high school, and college. And we are comparing their salaries. That's why we need to use ANOVA. How about this SOP here? Is there a significant difference in the academic performance of the participants when grouped according to academic strand? So we have 3 groups of academic strand here. STEM, AB, and HUMS. And dependent variable is academic performance in terms of grades. So you may use ANOVA. But let's have another one. Is there a significant difference in the antibacterial activity of Mayana leaf extract in the different treatment groups? So this is in pure experimental research. We have here different treatment groups. We have the control and experimental. Under control, we have the positive and negative. And under experimental, we have 25% concentration, 50%, 75%, 100%. So we have 1, 2, 3, 4, 5, 6. So we have 6 different treatment groups. So that's more than 2. So we need to use ANOVA or analysis of variance, but make sure the dependent variable should be numerical. And this is antibacterial activity. It should be something numerical. That is in terms of mean zone of inhibition. That is measured in millimeters. Another sample data, or for a sample data, in ANOVA, is there a significant difference in the academic performance of the participants when grouped according to academic strand? So to organize our data in a Microsoft Excel or in our SPSS, it may be like this. So you have the participant number, you have the strand for that certain participant, and the corresponding grade of that participant. Okay, so you may arrange your your data as to their strand, or it may be like this. It can be. It's actually the function of the SPSS to organize later on. Even this one is not organized as two strand, ABM together, HUMS together. It can be like this. Okay. You will learn more on arrangement or organization of data in my other videos. So please watch my other videos and statistical test. So for ANOVA, another example, is there a significant difference on the antibacterial activity? This in terms of ZOI, means zone of inhibition, of Mayana leaf extract in the different treatment groups. So you can arrange your data like this. You have the treatment groups: positive, negative, 25%, 50%, 75%, 100%. And then we have here replicates. So you have, for example, 3 replicates per each per group. Okay, so we have 1, 2, 3, 1, 2, 3, and then you measure their zone of inhibition. Okay, it can be like that, but you may also convert this to data wherein it can be treated using SPSS. So you need to do some coding for the treatment group. So for the group, for positive treatment group, you use 1, negative for 2, 25%, you use 3 for 50% leaf extract or concentration, that's for 4, then 75 for 6, 100 for, 75% for 5, 100% for 6. So here you use 1, 1, 1 for the positive here, the 3 replicates, and then this is their zone of inhibition. You have for the negative, use 2, 2, 2 for the replicates, okay? And then you have 3, 3. That's why you have 3 here because we have 3 replicates. You have 3, 4 because of the 3 replicates here. And we use for the 50% treatment leaf extract concentration. Okay, so that's it. That's how to organize our data so that it can be easily treated using SPSS. For the person R, a test for significant relationships. So these are examples of a research question or a statement of the problem. So make sure that for a person R, the independent variable or the predictor variable should be numerical, and also the dependent variables should also be numerical. Something you measure, something you count. Is there a significant relationship between students' study time and test scores? We know that study time, that's for example in hours, so it's something numerical. Test scores, it's numerical. So if you're looking into the relationship between two variables, you may use you can use person R. Another SOP, is there a significant relationship between the participants' study habits and academic performance? So study habits, you need to actually quantify this. So how to quantify study habits? You may use a Likert scale questionnaire, 5, 4, 3, 2, 1, and you get the weighted mean. In that questionnaire, you may have some statements, 10 statements, and then they will rate those statements as to 5, 4, 3, 2, 1, and that study habits will become numerical. And the academic performance is in terms of grades, and the two are numerical. That's why you need to you may use person R. Let's have an example of a data set. Is there a significant relationship between students' study time and test scores? So let's say, for example, you have 13 respondents here. So you need to have another column for study time that is in hours and the corresponding test scores. Let's say this is a 60-item test. And then you ask the first respondent, okay, how long did he actually study his lessons before the exam or the test? So he says, for example, 1.5 hours, and his corresponding test score is 28. Then the next respondent actually studied for 2 hours, and his test score is actually 35. So that's how actually to organize our data, okay, in person R. Another one, is there a significant relationship between the participants' study habits and academic performance? So as I said, study habits is actually quantified using a Likert scale questionnaire, 5, 4, 3, 2, 1, for example, and we get the mean. Okay, and academic performance is in terms of their grades. So for a participant, first participant, let's say for example the study habits is rated as 3.15, and his corresponding academic performance in terms of grade is 84. So you have to actually input it like this, and this is how you tabulate or organize your data in Excel, ready for the analysis using SPSS. Okay, as I said, you may watch my videos on statistical tests, okay, and Prison R and the other tests, okay, so that you can actually fully grasp what I'm actually discussing here. Okay, and for the other statistical tests for independence or relationship, we have what we call, or association, we have what we call chi-square test for independence. Okay, let's have this research question. Is gender related to course preference? So in a chi-square test, okay, our independent variable or one variable should be categorical and the other variable is also categorical. Okay, so is gender related to course preference? So our predictor here is gender. It's categorical because categorical are actually the nominal or ordinal. Okay, so gender is nominal. We have two groups, male, female. And course preference, let's say for example, in this certain study, we just consider two courses, nursing and engineering. So both variables should be categorical so that you can use chi-square. Okay, and this is actually a test of association or relationship. Is there a significant relationship between the participants' study habits and academic performance? If you still remember, I used the same SOP in our Person R, but the data that we use there for study habits and academic performance are actually numerical. In this case, or in this example, we are now going to use, okay, not numerical but categorical of study habit and academic performance in terms of levels. So this becomes ordinal, okay? So it's categorical. So you may use chi-square. So let's say, for example, study habit, you want your respondents, or you have to classify your respondents, no, according to their study habits as to excellent, very satisfactory, satisfactory, and so. And then for the academic performance, it's terms of level, whether they perform excellently or excellent performance. We have very satisfactory, satisfactory, and so. So your data here are ordinal. So they are not numerical, but they are ordinal. So that's why you may use chi-square test for independence. Let's have an example of a sample data or data set for chi-square test. Is gender related to course preference? So you may actually use or organize your data in this way. You have respondent number here, then you have the gender and the course preference. So for example, for respondent 1, okay, gender is male and the course preference in engineering. Respondent 2 is female and his course preference is nursing. Okay, so that's how to organize your data in Microsoft Excel or SPSS. Okay, another sample data. Is there a significant relationship between the participants' study habits and academic performance? So you have here the respondent number, then you have your study habits level, and then you have the academic performance. So if this is respondent 1, this is his corresponding study habits and corresponding academic performance level. So in here, you may actually treat this using Microsoft Excel or SPSS. Okay, so that's all. I hope you learned something today. Okay, and those are actually the things to consider to choose the appropriate statistical test for a given statement of the problem or a given research question. Okay, so thank you very much. Thank you for watching. See you in my next